I want to end this week of lecture with a quick discussion of missing values. We've seen a preview of how Pandas handles missing values using the NumType and NumPy NaN values. Missing values are pretty common in data cleaning activities. There are a couple of caveats and discussion points which we should address. First, the built-in loading from delimited files provides control for missing values in a few ways. The most germane of these is the NA_values list to indicate other strings which could refer to missing values. Some of my sociologist colleagues, for instance, regularly use the value of 99 in binary categories to indicate that there's no value, so this comes in handy. You can also use the NA_filter option to turn off whitespace filtering if whitespace is an actual value of interest, but in practice this is pretty rare. In addition to rules controlling how missing values might be loaded, it's sometimes useful to consider missing values as actually having information. I'll give an example from my own research. I often deal with logs from online learning systems. In particular, I've done a couple of projects looking at video use in lecture capture systems. In these systems, it's common for the player to have a heartbeat functionality, where playback statistics are sent to the server every so often, maybe every 30 seconds. These heartbeats can get big as they can carry the whole state of the playback system, such as where the video playhead is at, where the video size is, which video is being rendered to the screen, how loud the volume is, etc. If we load the data file log.txt, we can see an example of what this might look like. In this data, the first column is the timestamp in the Unix epoch format. The next column is the username, followed by a web page they are visiting and the video that they're playing. Each row of the data frame has a playback position, and we can see that as the playback position increases by 1, the timestamp increases by about 30 seconds. Except for user Bob. It turns out that Bob has paused his playback, so as time increases, the playback position doesn't change. Note, too, how difficult it is for us to try and derive this knowledge from the data because it's not sorted by timestamp as one might expect. This is actually not uncommon on systems which have a high degree of parallelism. There are a lot of missing values in the paused and volume columns. It's not efficient to send this information across the network if it hasn't changed, so this particular system just inserts null values into the database if there's no changes. One of the handy functions that Pandas has for working with missing values is the filling function fillNA. This function takes a number of parameters. For instance, you could pass in a single value, which is called a scalar value, to change all of the missing data to one value. This isn't really applicable in this case, but it's a pretty common use case. Next up, though, is the method parameter. The two common fill values are ffill and bfill. Ffill is for forward filling, and it updates an NA value for a particular cell with a value from the previous row. It's important to note that your data needs to be sorted in order for this to have the effect you might want. Data that comes from traditional database management systems usually has no order guarantee, just like this data, so be careful. In Pandas, we can sort either by index or by values. Here we'll just promote the timestamp to an index, then sort on the index. If we look closely at the output, though, we'll notice that the index isn't really unique. Two users seem to be able to use the system at the same time. Again, a very common case. Let's reset the index and use some multi-level indexing instead and promote the username to a second level of the index to deal with that issue. Now that we have the data indexed and sorted appropriately, we can fill the missing data using ffill. It's good to remember when dealing with missing values that you can deal with individual columns or sets of columns by projecting them, just as we spoke about earlier. So you don't have to fix all missing values in one command. It's sometimes useful to use forward filling, sometimes backwards filling, and sometimes useful to just use a single number. More recently, the Pandas team introduced a method of filling missing values with a series which is the same length as your data frame. This makes it easy to derive values which are missing if you have the underlying to do so. For instance, if you're dealing with receipts and you have a column for final price and a column for discount but are missing information from the original price column, you can fill this automatically using fillNA. One last note on missing values. When you use statistical functions on data frames, these functions typically ignore missing values. For instance, if you try and calculate the mean value of a data frame, the underlying NumPy function will ignore missing values. This is usually what you want, but you should be aware that values are being excluded.